Hey, this is Mr. Kelly at K-Town. We're talking about synthetic and long polynomial division. Woo, that's a mouthful. Tell you what, if you don't remember how to do long division from fifth grade, remember those big, ugly, problems that are on the board and they take forever, then what you need to do is make sure you go to Mr. Brust's room after school and find Mr. Brust because you guys need a tutor. You got to figure out how to do long division, both of you. Make sure you're both there so you can learn. He doesn't know how to do it either. We need to know how to do regular long division before we can do polynomial long division. But before we do any of that, I'm going to bring you back to substitution, subbing a value in. So what I want you to do, the first part says use direct substitution. That's just what you know how to do already. You just plug it in and figure it out. So pause the video, do direct substitution to evaluate this function when a equals -2. Go, pause the video now. I hope you enjoyed my quote there. It's from a famous person. They're rich. All right, so here's what we did. -2, plugged it in. I showed all the work because I'm a little worried about the signs there. -2 to the fifth power, that's negative, but there's a negative sign in front, so that's going to make it positive. So basically, this is going to work out to 32 minus 4 minus 2, that's -6, so that's 26 plus 5, that's all going to equal 31. So this equals 31. So the proper way to write this would be to say that t sub -2 is going to equal, t of -2 equals, what do we get, 31. All right, this is going to come up later. We're just going to put that on pause for now. Pause. Okay, so now I'm going to talk through the steps of synthetic substitution. This is a different way to substitute, and you know what? Sometimes it's a lot faster, sometimes not. Sometimes it's a lot faster, though. So I'm going to go through and read all these steps to you, but, honestly, let's just assume you can read. I'm going to go through these quickly, but I'm assuming you can read. And these steps here, I wrote them out so you could refer to them, but honestly, it's easiest just by watching it and figuring it out. But the steps are, as we said, step 1, you write down the value to be evaluated outside and the coefficients in descending order on the inside. You bring down a leading coefficient, you multiply, put the product underneath the next number, you basically add them as you're coming down, and you repeat the process until you're done. There, I summarized it. Let me show you how this works. First example, evaluate t of x equals this ugly function here when x equals -1. So step 1, you write the value to be evaluated at outside. So we're going to put a -1 right here. And what most people do is they make like an upside down division box like this. Then you write the coefficients of every single term. Now, you're going to notice right here there's a term missing. It's not really missing though. It's like 0x to the fourth. We have to put that 0 in there. Just like in numbers like 1021. What happens if we didn't include that 0 for the hundredths place? Then it's a different number, right? So we have to make sure that if there are any terms missing, we write their corresponding coefficients. We write a 0. All right, so the first coefficient is a -1. And then the next coefficient would be a 0. And the next coefficient would be a -7. And then the squared term is a 3. And then the x term, that one's missing as well. So there's 0x. So I need to put another 0. And the last number here is a -2. So that's when it says coefficients in descending order. And we're talking about the exponents descending. Exponents. All right? So the first thing I always do is I put an x right there and I bring down the first number. So now it's very simple. Multiply -1, this number out here, times -1. That is a positive one. That goes under that number right there. Then you add going down. So 0 plus 1 is 1. Then you multiply. You get a -1. Then you add. So once you get these steps down, multiply. You get -1 times -8 is a +8. Add going down. You get 11. Multiply. -11. Add. You get -11. And we're all done. After the step here, we get a 9. So everybody see how that works? So you multiply, put the number there, add. Then multiply, put the number there, add. And you go all the way down. Our last number here is 9. So we're done. That's how you do it. So this really is helpful if you have huge numbers here. But we would say that t of -1 equals 9. And we could check it by direct substitution. But we're just going to move on to save some time. So let's look at the next one. How would we set that up? Okay, so a being equal to -2, we put that out front. And then we make this upside down little division thingy here. We're going to put the coefficients. Now, there's a couple zeros right here. We get 1. Remember, we're putting the coefficients. There's no fourth or third term, so that's 2 zeros. We got a lot of 1s in this one. That's not cool by me. I should have put some bigger numbers, but whatevs. So we put -1, a 0 for the fourth, a 0 for the third, a -1 for the second, a +1 for the first, and then a 5 for the constant there. Now remember, the first one we always put an x, bring down the -1, and then the game is on. Here we go. Multiply and add. Here we go. -2 times -1 is a +2. Now we add. Now we multiply. Now we add, going down. So that's going to give us a -4. Now we multiply. That's going to give us a +8. Now we add. That's a 7. Now we multiply. -14. Now we add. That's -13. Now we multiply. 26. Now we add 31. 31, what? So we get t of -2 is going to equal 31. But guess what, peeps? That's exactly what we got way up here. We did it by direct substitution. It's the same problem. Haha. Got you. Did you notice it was the same problem? But you get the same answer either way. So that's why I picked the same problem there. It's time for you to try one all by yourself. So evaluate this function at x equals -3 all by yourself. Pause the video. Go! Okay, peoples. I got a very nice and even 350, and you can see my work right there. Go through and check it. If you have any questions, put it in the corner and go talk to your teacher about it. All right, so now as a review of long division, I'm going to bring in a little bit of Mr. Wagnese. I got to be honest, stole this off of YouTube, so shout out to Mr. Wagnese. We're going to put a little bit of your song in here. Okay, now that I'm in Sully's hallway, I would love to hear kids sing that going into his room. Come on, just go into Sully's room, sing the Divide song by Mr. Wagnese. By the way, big shout out. I'm going to put that whole song at the end of this lesson because it does have to deal with polynomial long division. That's actually the point of that song, and so you can watch the whole thing there. Very creative guy. All right, so I'm going to basically give you the hardest type first. This is a huge problem. It's got every different thing you can think about in it, and then the rest of them should be easy. That's my thinking here. Okay, so if we're going to divide long division, it works just like it does with regular 2 and 3 digit numbers. What we're going to do is we have the divisor and the dividend. Those are basically the thing that you're going to start with, the thing you're going to divide by. This is the divisor. Okay, the divisor goes out front. That's just like normal. So I'm going to write that out front here. X squared minus 3x plus 5. And we know division looks like this. We draw a big line. Then we write the dividend underneath, so we get 3x to the 4th. Now, here's the thing. Let me tell you about the thing. The thing is, do we have an x term? No. Let me show you a number here. This is the number 1021. Do we have a hundreds term? No, so we put a 0. Here we don't have an x term. Oops. So because we don't have an x term, we have to put a 0. So we're going to put plus 0x squared. We do have an x term here. 4x and then a minus 6. All right, so we just write it as we normally would if they were numbers. Okay? Now what? Let's try to change some colors here. We're going to change it up. The way I think of this, it's dividing. So, if you wanted to, you could go like this. 3x to the 4th divided by, look at the first term, x squared, and they cancel, and that leaves a 2, leaves you 3x squared. But that's essentially what we're doing, but what I want you, it's probably easier way to do it is to think, you have x squared. What do you need to multiply by to get to 3x to the 4th? That's basically what division is. It's backwards multiplication. So you could take x squared. How can we get to 3x to the 4th? Well, we're going to need a 3. We're going to need an x. Actually, we'll need 2 x's. So we're going to need a 3x squared. It's the same answer we got before, but it's a different way of thinking about it. Okay, now just like with long division, as soon as you put that part of the quotient on the top, you need to multiply through. Now, this is like distributive property. You're going to multiply everything through. So as we do that, we should get 3 terms. So what's the first term going to be? Should always be the same. 3x to the fourth. Okay, when you multiply here. Okay, the middle term, you get 3 times negative 3, that's negative 9. You get x squared times x, that's x to the third. Notice how the terms match up now. We have the fourth, we have the third. This one should be the squared. Multiply 3, we get a positive 15, x squared. All right, draw your line. Now, what's the next step in long division? We need to subtract. Now, this is where it can be a little tricky, so what I do is I subtract, I put little parentheses around, just to remind me in cases like this is easy, 3x to the fourth minus 3x to the fourth, they cancel, it gives you a 0. You don't have to write that. But we have a negative 5 minus negative 9. Okay, and most students forget it's minus the negative, so that's going to give us a positive 4x to the third. Okay, 0 minus 15, a positive 15. 0 minus 15 is a negative 15x squared. So the next question is, what do we do next in long division? We bring down. We bring down from up here. It's going to be that 4x. So it's a positive 4x or plus 4x. So now we have a trinomial again. Guess what? We play the same games all over again. So how do you go from x squared to 4x to the third? It's how many times does this go into that? What do you multiply by to go from x squared to 4x to the third power? You need to multiply by a positive 4, and you need another x. So now it's multiplied through. Don't forget to distribute. So we get 4x to the third. 4 times negative 3, that's a negative 12. And we have x times x, which is x squared. And notice everything's lining up nicely for us. We have 4x times 5. That is a positive 20x. And we need to subtract. And as I said, I like to use parentheses here so that we don't forget to subtract our negatives. We have negative 15x squared minus negative 12. That's going to be a negative 3x squared. And we have 4 minus 20. That's negative 16x. Next step, I'm going to change colors just for fun. Bring down that negative 6. All right, now what? One more to go. So we have x squared. How do you go from x squared to negative 3x squared? All you need is a negative 3. And notice how the degree is going down and down and down in each one of these terms. You have a squared, you have a single x, and then you have no x. So that should happen every time. If it doesn't, then you probably forgot that 0 in there. But multiply through, negative 3x squared. We get a positive 9x and a minus 15. Now the last part, I need to subtract this because we are going to get a remainder here. Say what? We're going to get a remainder. They're going to cancel. Negative 16x minus 9 is negative what? 25x. And then negative 6 minus negative 15. Is that going to be a positive 9? There we go. Positive 9. So how do we write this? If you remember back in elementary school, they tell you to take this number here, the remainder, and then you write it over the divisor. So this is going to be, because here's what I'm going to do to be safe. I was going to say you can subtract, but it gets tricky because you did subtract the whole thing. Then you got to be careful of your signs. So I'm just going to say plus, and then I'm going to use parentheses. Negative 25x plus 9 over, and then x squared minus 3x plus 5. And that is that's the part that's the remainder. And here's our answer. So the final answer is 3x squared plus 4x minus 3 plus this out of that. Negative 25x plus 9 out of x squared minus 3x plus 5. Okay, I must be honest, that was totally crazy. But I'm going to fly through this one. You're going to see it's going to work a little more structured. I'm going to go through it. There'll be a rhythm to it. So let's get started here. All right, we're going to divide 6m to the fourth minus 12m cubed plus 0m squared because there's no squared term plus m minus 2. We're dividing that by m minus 2. Here we go. So as I said, I asked myself, how do you go from m? I'm going to look at the first term. How do you go from m to 6m to the fourth? That's going to be a 6m to the third. That's what I'm going to need. And I'm going to have to multiply through. So that's going to give me a negative 12m to the third, right? All right. Now subtract. I'm drawing my parentheses so I don't forget. 6 minus 6, they cancel. Negative 12 minus negative 12, they cancel. So I'm left with a 0m to the third. And now I need to bring down a 0m squared. Cray. That's crazy. So now you ask yourself, how do you go from an m to a 0m to the third power? Don't think too hard here. So you need a 0. So we're going to do plus 0. And you need 2 more m's. So it's 0m squared. Let's multiply through. 0m squared times m. That's 0m m to the third. Yes, it just equals 0, but we're going to write it out so we don't lose track of our terms. 0m squared times negative 2, that is also 0m squared. Wow, so they cancel. Remember, we're subtracting technically, and they're going to cancel too, so you're going to be left with a 0m squared. Now let's bring down the m, plus m. So now we're starting to get somewhere. So how do you go from an m to a 0m squared? Plus 0m. So multiply through again. Yeah, I picked one with a lot of zeros because it happens sometimes. You get 0m. Let's subtract now. So they cancel. 1 minus 0, that would be 1m. We're going to bring down that negative 2. So how do you go from m to 1m? You need a positive 1. So you multiply through, you get m minus 2. Guess what? They cancel out. You get a 0 at the bottom. So that 0 means there's no remainder. We're all done. Do we need to write these 0 terms? No, we don't. Final answer for B, 6m cubed plus 1. Hey, that was a little bit easier. Tell you what, you try one. Try part C by yourself right now. Go! All right, here's what I got for letter C here. If you go through, we do have some zeros in this one as well, where you have to be careful. You have to add a 0 right here. Did you remember to do that? Because it was just minus 21n, and there's no constant at the end, so you need to add that 0. But it didn't matter in this particular case anyway, because it all worked out to 0 with a remainder of 0. Final answer here, n to the third. Don't need the squared term, minus 7n. That's your final answer. Hey, how about that? Let's look at a new way. Okay, the new way to do it. This is called synthetic division. Whoop, I don't know what's going on there. This is called synthetic division. Now, the great thing about synthetic division is it's quicker, it's more efficient. I could write all those steps down for you, but I'm not going to do that. That'd be crazy. I'm just going to show you how to do it. Let's just see how to do it here. Here's how it works. It's very similar to synthetic substitution. Now, if you remember, let's go back. Synthetic substitution. Where'd it go? Where'd it go? Oh, whatever. All right, here. Notice how you put the number out front that x is equal to. We did that, right? The number that x is equal to goes out front. That's what we did earlier. So if x equals negative 2, you put a negative 2 out front. You do the same thing right here. Now, this means it could be a little tricky because when we divide by x minus 2, that's not what x is equal to. That is a factor. We need to look at the root. So if you remember when we basically solve these equations, and we know that one of the factors, this is going to be a factor if it divides into it. If it divides into it. It's going to be a factor, so that means it's a 0, which means that you're going to have x minus 2 is going to be equal to 0. Oops. So long story short, x is going to equal 2. So in this situation, you're going to put a 2 out front when we do our synthetic division. It's very similar to synthetic substitution. Let me scroll down a little bit so you can see a difference. Notice in F, they already tell you what x is equal to. So you don't have to go and figure it out. And by figure out, I mean it's basically the opposite. This is x minus 2, so you put a positive 2 out front here. But down here, x equals negative 2, you'd put a negative 2 out front. You do not change it. So that is one slight thing you have to be aware of. But the way this works, very similar to synthetic substitution, we're going to put all the coefficients in here. So we got a 1, a 5, a negative 7. I'm looking to make sure that there aren't any terms missing, and there are not, so we're good to go. I put an x there and bring down the first number. So this works very similar. You multiply, put the product right here, then you add. Here we get a 7. Multiply, get a 14, add. Multiply, add. Guess what? We're all done. We just divided that. You're like, what? How's that possible? Well, let's think about it. When we divide, we have an x to the third power. If we divide an x out, what's going to be left over? An x squared. All right, so that's what this coefficient represents right here. This is x squared, 1x squared. I'll put a 1 there just so we know where that went. And that means that the next one is the x term. And the next coefficient is the regular number. What about this last one here? That is the remainder. So it's 16 out of what? The divisor, which in this case would be x minus 2. See how that works? We're all done. Is that faster than long division? You betcha it is. That's why we want to learn it this way. Some of you are probably going, what? Others are going, what's the homework? Let's try E. is determine if this is a factor. Now, what does a factor mean, by the way? We divided this. We got a nice thing. We got a nice remainder. But what is a factor? Can we back that up a little? Like, is 5 a factor of 12? Well, if I divide 12 by 5, what do I get? Well, a long time ago, we'd say 2 and 2/5. Okay, didn't work out evenly. What if I divide 12 by 3? Then I get a 4. Oh, it worked out evenly. No remainder. So that's what we're looking for right here. If you divide this and there's a remainder, then it's not a factor. But if the remainder equals 0, which means there's no remainder, then it is a factor. It's that simple. Let's do this one. X plus 3. All right, so that means I got to put a minus 3 out front. Let's draw our synthetic substitution with all of our coefficients. Not forgetting any, am I? I don't think so. Put an X there, bring it down. Now it's multiply and add. We get a negative 5 there. Multiply. Negative 3 times negative 5 is 15. We add. That's going to give us a 7. Multiply. We get negative 21. And we get a 0 here. That's the remainder. The last term's always the remainder. So when we divide this polynomial by x plus 3, our answer is going to be 2x squared minus 5x plus 7. And there's no remainder, so I don't have to worry about it. But guess what? Now we can factor that because it says if so, then factor completely. So the first factor was x plus 3. And now, because it divided evenly, I can say that the other factor must be 2x squared minus 5x plus 7. Oh, now we have to factor that. So how does that factor? Well, however you learned how to factor, there's a couple ways to learn how to factor. But we got a 2. How do you get a 2x squared? A 2x and an x. And then there's different ways to do it. The middle term's negative, so these must be negative. So I'm going to do minus 7 minus 1. What's that going to give us? Minus 2. Nope, that doesn't work. Oh. Okay, so does this work? Well, I multiplied out. No, it does not. What if I change this to a 1 and that to a 7? What do we get? Negative 4. Okay, so nothing works. So guess what? This was factored completely. That's factored completely. I can't go any further. That's it. However, I must warn you, I should have picked an example where that factors further, but maybe there's one down here. You never know. If it says factor further, then check it. If it factors, then you got to keep going. So let's try the next one. Suppose you know that x equals negative 2 is a 0 of the function. Remember, I said this is the root. That's what x equals to, so that's what's going to go out front. They want you to find the other zeros. Now remember, the zeros where it crosses the x-axis. If we can factor it and set it equal to 0, that's basically where we want to go here. This whole chapter, is a lot of it's going to be factoring it, set it equal to 0 when you have to solve any equation or find the zeros. So we know that x minus 2 is a 0. So let's, what do we get? 1, 2, negative 9, negative 18. So put an x there, bring a 1 down. So negative 2 times 1 is negative 2. We get a 0. Get a 0 again. Negative 9. We get an 18, and it works out. So it is a 0. We know that. We got a remainder of 0. Let me say that all again. X equals negative 2 is a 0 of the function because we get a 0 for the remainder. There's no remainder there. So how does this answer here translate back into a polynomial? That would be an x squared plus 0x. I'm not going to write plus 0x. We don't need to write that. Minus 9. Okay, now we need to find the other zeros. So we know that x equals negative 2 was a 0. So that means that x plus 2 is a factor. And we just got x squared minus 9. That's a factor. Now remember before when I said, oh, I wish that second one factored again? This is a difference of perfect squares. So you get x minus 3, x plus 3. Okay, and then you can set all three. We want to find the 0, so we want to know where this equals 0. We want to know where this equals 0. So this will equal 0. If any of these equal 0, we already know the first one is x equals negative 2, or we can have x minus 3 equals 0, or x equals 3, or in this case over here, x equals negative 3. So look, I just found all of the zeros just by dividing it out using synthetic division and then setting all the factors equal to 0. The only tricky part there, we got to go from here back to the factor. So it's just the opposite, right? And that's the only tricky part there. All right, last thing, application problem. Okay, so the application problem involves the profit we make. Algebros making some t-shirts. And x is the number of shirts made in millions. So when I have x equals 2, it's 2 million shirts. Okay, currently the company produces 4 million shirts and makes a profit of $4 million. Okay, the profit is also in millions of dollars. So we need to be careful with our units here. So let's write down our function. So P is going to equal negative x cubed plus 4x squared plus x. This is like how you think. I'm going to think through this application problem. So they tell us some information. When we make 4 million shirts, then the profit is 4,000. We want to know when else the profit will be 4,000. That means there's a 4 here. So when will 4 equal this ugly function that we have? Well, you know what we can always do? We can always set equal to 0. That's usually a good thing to do because then we can use our zero product property. So I'm going to move that 4 over by subtracting 4 from each side, and then I get this function. Now, I know that 4, which represents 4 millions, will make that profit. In other words, we'll solve this equation, right? So 4 works. So what I'm going to do is I'm going to write this. Here's a function. I know that if 4 works, then x minus 4 is a factor, right? So one factor is x minus 4. Okay, so maybe we can start factoring this thing. But the value, we know that 4 is a 0, so 4 goes out front. Let me change this up. Let me change the color up. 4 goes up front. And we have this ugly, I don't want to do it like that. I want to do it like this. So 4 is, this is tricky because we have two 4's here. One represents the P, and I already plugged that in. But we know when x is 4 that's going to solve this equation. Okay, when I plug a 4 in here, it's going to solve this, which means it'll solve this equation right here. So I want to know what other values will solve this equation. Let's take this function here, this polynomial, and we'll divide it by x minus 4. We can use long division if you want to, but I'm going to use synthetic division. I'm going to find and put the 0 here. I'm going to write the coefficients. And remember, I always put an x there and bring down a -1. Let's start playing the game. So remember, it's multiply and then add down. Multiply, add down, multiply, add down. So look, this is a very simple function. Remember, the last one here is going to be the remainder. So there's a remainder of 0. That means we get -1 x squared minus 1. Okay, so what does that mean? That is another polynomial. What do we got? X minus 4, and we just figured out that -1 x squared minus 1 is also a factor. Oh, I'm sorry, plus 1. Sorry, plus 1. Kelly screwed that up. That's a positive 1. All right, so watch this. This is very close. This is almost a difference of perfect squares. But I can play a little trick here. Here's my trick. That x minus 4 is going to hang out. But I'm going to factor a -1 out of this second factor here. So what's that going to do? That's going to give us an x squared minus 1. Guess what? Now it's a difference of perfect squares. This is going to be equivalent to, we have our x minus 4, we have a -1, and we have x plus 1, x minus 1. All right, so this whole polynomial right here, I just broke it down into this right here. You might be asking, why did we take the -1 out? Because I recognize this is almost a difference of perfect squares. If the signs were opposite, it would work, so I factored a -1 out. And then it made the signs opposite, and that means I could factor it. So that means that x plus 1 and x minus 1 are both factors. So if x minus 1 is a factor, that means x equals 1 is a root. If x plus 1 is a factor, that means that x equals -1 is a root. We know that x equals 4 is already a root. So we already know that one. One of these does not make sense. Which one? The negative, because you can't have negative number of shirts made. So the answer to here would be x equals 1. Can the company make a lesser number of bro shirts and still make the same profit? Yes. So the answer is yes. They can make 1 million shirts. All right, and that's it. That's the application problem. Woo, sorry, this is a long one, but hey, this is complicated stuff. If you have any questions, see your teacher. This is Mr. Kelly in K-Town. Remember, it's nice to be important, more important to be nice. See ya!